Chapter 1-5, Solving Inequalities. Today we'll be talking about inequalities, and the most important thing you need to know is, what is an inequality? So, if we're talking about inequality, inequality means something that is not equal. So therefore, what is an inequality? It's a statement where the right and the left-hand sides are not equal. They could be equal, but they're either less than, greater than, or not equal to. So the symbols that we're going to be using: not equal to, less than, pointing to the left, greater than, pointing to the right, less than or equal to, pointing to the left, greater than or equal to, pointing to the right. And again, if you remember this, we talked about the alligator and the crocodile and Pac-Man stuff that you all do. And I told you I don't want you guys to do that. I want you to put 0 on the number line. I want you to think all the numbers to the right of 0, arrow pointing to the right, are greater than it. All the numbers to the left, arrow pointing to the left, are smaller than it, so therefore that's the less than symbol. Okay. Graphing rules. A closed dot means that the number is a solution. It is allowed to be that number. Okay? We'll physically see a closed dot there. It's allowed to be that number. An open dot means the number is not a solution to the problem. Meaning you can have all the numbers right up to that or right before it, but you cannot physically have that number. Okay? Now, the biggest rule that you need to remember, the most important. You solve these exactly the way you solve equations, except for there's one important rule. When you multiply or divide by a negative number, you must flip the inequality symbol. You have to. If you don't flip the inequality symbol, you are going to get a false statement. And the point of solving an equation and in solving an inequality is to make the statement true. And the only way you can make the statement true is by making sure that you flip the sign when you multiply or divide by a negative number. Okay? Why do we flip the sign? Again, to make the statement true. Do we all understand that? So, our first example. Negative 2x plus 4 is equal to 8. Now, we're going to pretend, just like whenever you tell your parents that you're going to clean your room and that you cleaned it all, put it all away. We're going to pretend that that inequality symbol is an equal sign, and pretend that it's not less than symbol right now. So if we do this, if we pretend that's an equal sign, what would I get rid of first? The first thing I would get rid of is the 4. So I have to subtract 4 from both sides. So negative 2x, 4's cancel out, is less than positive 4. Now I need to solve for x, so how do I get rid of that negative 2? Well, I divide by negative 2. Now, did I divide by a negative number? I sure did, so those cancel out. And now I'm going to flip the sign and make that greater than negative 2. Okay? That is your final answer. Now, I want to plug and chug values in for x and see what values make this a true statement. This says that all the values to make this a true statement are going to be values that are bigger than negative 2. So a number bigger than negative 2 is going to, let's say, positive 2. So negative 2 times 2 plus 4 is less than 8. This is negative 4 plus 4 is less than 8. Negative 4 plus 4 is 0. Is 0 less than 8? Yes, that's a true statement. Now, what would have happened if I would not have flipped my sign? I'm going to get a false statement. So let's choose values smaller than negative 2. So let's choose negative 3. So it's negative 2 times negative 3. That gives me a 6. 6 plus 4 is 10. Is 10 less than 8? No, 10 is not less than 8. This is a false statement. So if we would not have flipped our sign, what you would get is all the answers that make the statement false rather than all the answers that make the statement true. So make sure that you flip your sign. Okay? Again, why did I flip my sign here? Because I divided. I didn't flip my sign when I subtracted. I did not flip my sign when I subtracted 4. Okay, so the sign stayed the same there. When I flip my sign is when I divided by negative 2. Let's do it again. Okay, well, here we have some ugliness going on here. So how do I get rid of my fractions? Well, what's my LCD? My LCD between 6 and 2 is going to be 12. So I'm going to multiply the entire inequality, not equation, but inequality, by 12. And actually, that's not my LCD. I apologize. My LCD is 6. Those of you girls in here saying this is good or you're wrong, well, you did a good job. I was wrong. 6 divided by 6 gives me a 1, so I drop down my R. Go to the next one. 6 times -5 gives me -30. Do I flip my sign? Notice I'm distributing to that sign right now. Why? Because I want to know, did I multiply this by a negative number? And I did not, so I keep my sign. Go to the next one. 6 times 7 gives me 42. Go to the next one. 6 divided by 2 gives me a 3 and drop down the R. So go ahead and subtract R. And I have -30 is greater than 42 plus 2R. Now, I'm going to subtract 42. Notice I'm not flipping my sign. So this is going to give me a -72 is greater than 2R. And now what do? I divide by 2. When I divide by 2, this is going to go into it 3 times. That's going to give me a -36 is greater than R. I did not flip the sign. Now, here's my issue. Many of you are not going to be able to look at that and graph that appropriately. So what I want you to do is I want to pick this up and I'm going to swap it around. The arrow is currently pointing toward the R, so the arrow still needs to point toward the R. This is the answer that I want to see. Okay, now how do I graph that? Well, I'm going to put -36 on the number line. Can it be -36? No. Why can it not be -36? Because it's not an equal to sign there. Okay? And I want R is less than -36. So if R is less than -36, I'm going to shade to the left. Okay? Shade to the left. Okay, what about this one right here? I have -1/3 is parentheses times n-5 is greater than or equal to 11/3. Now I need to go ahead and get rid of that fraction. How do I get rid of that fraction? I'm going to multiply by what? I'm going to multiply by 3. Okay? So that gives me -1 times n-5. Go to the sign. Do I flip the sign? No, the sign stays. Go across. 11/3 times 3 gives me 11. Now what do I do with that negative sign? Well, there's 2 things you can do here. You can divide or you can distribute. Many of you are going to distribute, so I'm going to distribute. -n plus 5 is greater than or equal to 11. Now I need to get rid of that 5, so I'm going to subtract 5. -n is greater than or equal to 6. I need to solve for 1n, not -1n, so I'm going to divide by -1. Now, did I divide by negative? I did, so I flipped the sign to get -6. My variable's on the left, and now I'm going to go ahead and I'm going to graph this. I put -6 on the number line. Can it be -6? Well, this says it can be less than or equal to -6. So it's a closed dot at -6. And I want all the values where n is going to be less than -6, so I'm going to shade down to the left. Okay? Compound inequalities. Compound inequalities are any inequality that has an and, an or has 2 signs. That's the words and, or, and or has 2 signs. Okay? Has the words and, or has 2 signs. An and inequality, you must find all the values that make both inequalities true. An or inequality says that you must find all the values that make one or the other inequalities true. So it can be one of the true answers or the other one can be true. It does not have to be both. Now, examples. These are graphs of compound inequalities or just regular inequalities. So what we're going to do is we're going to figure out the answer here. Well, I have shaded region going to the left, and I have a closed dot here, or an open dot. So what does this say? Well, the shaded region represents x, so I'm going to have x as my shaded region. And then I have my wall. My wall is where I stop. I run into a wall and I can't go past it. My wall stops at 3. Now my question is my shading going to be below 3, above 3, less than or equal to 3, meaning it can be 3, greater than or equal to 3, meaning it has to be larger than 3, but it still can be 3. Now, since it's an open dot uses these three symbols up here on the top left: less than, greater than, or not equal to. So since it's an open dot, those are my options. Is the shading to the left or to the right? The shading is to the left, so therefore it's strictly less than. Okay? Now go to the next one. My shading is going to be to the right. I have my X that I always put first. Okay? I have my wall, which starts at -4. Can it be -4? It's a closed dot. A closed dot means I'm going to use these values over here. Less than or equal to, greater than to, or equal to. Well, as soon as you see shading, you know you're down to two signs: less than or equal to, or greater than or equal to. So, with that said, I want X. X can be -4, so I know I have part of it equal. And I want all the values that are to the right of -4, so that means X is larger than -4. So X is greater than or equal to -4. Okay, this one right here is what we call an OR. Okay? X can be below -1, or X can be greater than or equal to 1. Okay, it can be above 1. So let's go ahead and write that. That's going to be, I have X, and I have my wall. My wall is -1. If I read this part, that means it's going to be open, and it's going to be strictly less than that. Put the word OR in between there. And now write this one. I have X, and I have my wall where it starts, which is 1. It can be 1, so it's going to be greater than or equal to. Now, this one is trapped. My shading is trapped between two numbers. This top one was an OR. This second one is going to be an AND. It is the combination of two of these graphs, which means I'm going to put my walls up. X is my shading, which means it's in the middle, and my last wall is going to be 4. Now, tell me this. What's the relationship between -6 and 4? -6 is always less than 4. So if I take X out, I know I have less than symbol right there. -6 is less than 4. But I have to put X back in, which means they both have to be less than. Okay? They both have to be less than. Now my question is can it be -6? No, it cannot, so that stays as the less than symbol. Can it be +4? It can, so that less than symbol turns into less than or equal to. Okay? Now look at this one. Again, this is an AND. How do I know this is an AND? Because they are stuck between two walls. My walls are going to be -10 and 7. I put X in the middle. Why is X in the middle? Because the shading is in the middle. And just like the previous example, X is trapped between two numbers, so therefore the relationship between -10 and 7 is always less than. And I asked the question, can it be -10? Is it open or closed? It's closed, so therefore I add the less than or equal to symbol. Can it be 7? No, it can't, so it's strictly less than, and this is done. Now, what you need to know is when X is trapped between two walls, the symbols you have to use are less than or less than or equal to every time. Okay? Now, we're going to do a compound inequality. This is a compound inequality. Why? Because what you see here is two problems. Here's one problem, and here's the second problem. So if you had this problem, what would you do? Well, you would go ahead and distribute. So that gives you -3 is less than 6x plus 2 minus 5. And then what I'm going to do is I'm going to drop down less than or equal to 11. Now what would you do? You would combine like terms in the middle, right? So -3 is less than 6x minus 3, which is less than or equal to 11. Now if you had this problem, what would you do? You would add 3 units to both sides. Well, now we're going to add 3 units to the left, to the middle, and to the right. So this gives me 0 is less than 6x, which is less than or equal to 14. Okay. Now, if you had just this problem, what would you do? Well, you would divide by 6. So we're going to divide the left, the middle, and the right by 6. So that gives you 0 divided by 6 is 0, is less than or equal to is less than x, which is less than or equal to 14 over 6 reduces down to, divided by 2, 7 over 3. This is your answer. This is an and. Why is it an and statement? Because x is tracked. So how do I track that? I put 0, and I put 7/3. Can it be 0? No, it cannot, so it's open. Can it be 7/3? Yes, it can, so it's closed. And I'm going to shade in the middle because that's where x is currently at. Okay. This is also an and. So I'm going to solve each one of these individually. I'm going to subtract 1. So that gives me 6 is less than 2x. Divide by 2. 3 is less than x. Now, I don't like the way that looks, so I put the x to the left. I put the 3 to the right. The arrow is pointing to the 3 up top, so the arrow is going to point to the 3 on this one. I box it in. Write the word and. I come over here and I solve this one. Divide by 3. X is less than or equal to 6. So now I'm going to put these both on a number line. Well, here's 3. Here's 6. 3, it cannot be 3, so it's open, and I shade to the right. Here's 6, it can be 6, and I'm going to shade to the left. Now, where do they overlap at? They overlap right in the middle. So how do I write that answer? 3, 6 are my walls, x is in between, strictly less than every time. You always use the less than symbols. It's open at 3 and it's closed at 6. So this is your final answer. This is not an answer. This is not an answer. This one right here is your final answer. Okay? You have to combine them together. Now this is an or. So how do I write this or? Again, solve them each individually. Subtract the 7. X is greater than or equal to -1. Or subtract the 8. X is going to be less than -5. So now I'm going to put them on a number line. I have -1 here. I have -5 here. -1, it can be -1, and I'm going to shade to the right. This one right here cannot be -5, and I'm going to shade to the left. This is an or statement, and these two together are your answers. Okay? Or means they go in opposite directions. Or means they go in opposite directions. Okay? Tonight's homework is going to be your worksheet. Okay? I have a couple of these that I'll go ahead and put on the website for you, but that's the extent of our video. One more thing before I let you go, though. I do want to cover number 15, where we actually have to write an inequality. It says 4 less than a number is greater than -28. 4 less than a number. Do I know what the number is? Nope. So I'm going to say the number is x. It's 4 less than that. So that's going to be -4. It is greater than, strictly greater than, -28. It didn't say it could be 28. It said it's greater than. And this is going to be your inequality. So, you guys go ahead and do your worksheet. I answer any and all questions you have tomorrow. Have a great day.